Hi, I'm Viktor, Simulation Specialist at PLM Group. In this video I will go through the workflow for the basic setup of the strength analysis of a part on Simulia 3D Experience. I have the model open, I am at the top level, and there's geometry, there's a FEMREP. The FEMREP has a TET mesh and the solid section, and material is applied. So everything is ready to start the simulation. So from the top level I go to the compass and I will open one of the scenario apps. So depending on what role you have, you might have different scenario. This one is totally linear. This one has the regular static analysis and much more, and this one has most of the analysis types that are available. We're going to do everything linear so we can stay in the linear structural scenario, but the same procedure will be for all the apps. So I click that one and it's going to create a simulation, and I can name it, and I can say that we want to have a structural analysis, and we can name it here like this. Analysis case name, default, and here I can select the FEMREPs. So if you have several, you can choose which one to use here. So I'm going to pick the only one existing. You can also create a completely new one here. And OK. And the top level container is the simulation, and it has the model, the scenario, and the result. So in the scenario we have one analysis case which is totally empty, so we need to do the setup. Here we have the analysis case and there are no procedures yet. If we want, we can use the assistant here and let it guide us through the setup. The first thing is the procedure or the step. So I'm going to go to the procedures tab and add the static perturbation step, or a static step if you do it in another app. Static perturbation step, so it's a totally linear situation, and OK. And now it's here, there's a static perturbation step with some default output requests, and we can set it up here. So I'm going to go to the boundary conditions and check what we have. I'm going to use the hinge. So I'm going to double click on the hinge so the menu stays open. And then we're going to fix with this hinge condition the holes here. If it's hard to grab the holes here, I can open the visibility manager here. Let's position these. And I can hide the FE models. So we pick 1, okay, 2, okay, 3, okay, 4, okay, cancel. So it should be in separate conditions. Then we need to add a load, so I'm going to the load tab, and we have the force or various tools here. Let's add the remote force, which is going to be in the center here. So it's going to act from the center. It gives us the center position per default. Here I want to put it at an angle. So how do we control the direction of the force? Well, we can use these buttons here. This is the simplest way. It's of course possible to create a coordinate system as well and use it here. But we can also do it here. So we can align this, align the triad with the global coordinate system. Or here, align the triad with some geometry. So I'll pick that one, and then I will select this hole here. It's going to be the axis that pops up. And now the coordinate system is aligned according to the axis. And now we can pick direction, or we can rotate here. So I'm going to rotate around the y-axis 45 degrees and click. And now we have a z direction that points at a 45-degree angle. So we can put 500 Newton there. And that's going to be the force application. And OK. So we have force and the hinges applied. And according to the assistant and the guide, everything is done. Everything is set up and ready. So we can run and get some results. A tip if you are looking for reaction forces, that is to add to the output requests. So I'm going to the Simulate tab down here, and I'm creating an output request, and I'm going to create that for the nodal forces, because that enables the enhanced resultant sensor. And it also makes the result file a bit larger. And I believe we are ready, so I can run the update, or click Ctrl U, or click down here in the action bar and do a save. Ctrl S, or go to the arrow in the top right and click save. A few more things before we are done with the setup, just so we find our way around here. With these buttons here, we can switch to the model mode, and then it basically opens the FemRep. The FemRep is here, so we can double click on this one. If I double click on the FemRep, it's the same as switching to the model here. And now we are in the structural model creation app, and we have here all the tools for meshing and connections, and check the element quality available. If I click on the scenario button here, it switches back to the scenario, and we have the boundary conditions available. And here we can switch to viewing the results when they exist. To get an overview of the simulation, we can check in the tree to the left that we have the static perturbation step with force, hinges, output requests. Another overview is available in the feature manager, which is quite nice. And it shows us for the static perturbation step, we have all this set up. So I'm going to run this one by clicking the simulate button down here in the action bar. Click on that one. And here, depending on your role, you can run it on cloud cores. You have different number of cloud cores available. I can choose to choose that here, and 4 cores, 8 cores, depends on the role for cloud. This is a tiny model, so maybe the local cores are enough, and I'm just going to run it on 2 local cores. So I'm going to click run and let it simulate, and we will check the results in a different video. Thanks for watching.